Hi guys, welcome to a lesson of partial differential equations. So in today's class, we are going to discuss a quasi-linear first order partial differential equation in higher dimensions. So let's take a problem for quasi-linear in higher dimension. We have ut plus u times ux plus t times uy equals y, and the given initial condition is u of x comma y comma 0 it's equals to x. Now let us construct the Lagrange form for this quasi-linear in higher dimension, and this equation corresponds that the solution will be of the form u of x comma y comma t, which categorically uh, represents that this u is a function of three independent variables. So first of all, we'll construct the Lagrange form. So that is dt over 1, that is the coefficient of ut is 1, and then this is equals to dx over u, this is equals to dy over t, and this is equals to du over y. Now we can see that some of the pairs are separable and we can use these pairs. So we can use this pair with this one dy over t. So it will be t dt equals y, dy. So we can integrate both sides. So it will be t squared over 2 plus c equals y, call it equation 1, and then apply the initial conditions. So what initial condition says, we have u of x comma y comma 0 equals x, where this implies that u of 0 is equals to x naught, because u at 0 is equals to x, so we can say that it's x naught initially, and then x of 0 is again x naught, because this thing here represents the initial condition for x, and we can say y of 0 is equals to y naught and t of 0 equals 0. Here this 0 represents the initial condition for t. Now if we plug these initial conditions in equation number 1, so equation number 1 implies that 0 plus c equals y naught. So c equals y naught means 1 implies t squared over 2 plus y naught equals to y. Now what we can do is we can use this expression for y in any other pair. So now what we can do here is that we can see now we have the value of y in terms of t, so we can replace this y with the value of y, that is t squared over 2 plus y naught, and then use this with the pair dt over 1. So it will be separable, so let's do it here. We have dt equals du over y, so instead of y, keep it like this, t squared over 2 plus y naught, and now this is separable. Just take this denominator to the left side, and this is separable, so we can integrate the equation to get the result for u in terms of t. So it will be t cubed over 6 plus y naught t plus c1 equals u. Now again, applying the initial conditions for t and u. So we have 0 plus c1 equals x naught, because u of 0 equals x naught. So again, if you call it equation number 2, then equation 2 implies that uh, t cube over 6 plus y naught t plus x naught is equals to u. So we can box this expression. Okay, now what we can do is we can take other pair, that is if you can see here, okay, so now we have this expression for u as well. Now let's work for other pair. So now we can do one thing, that we can replace u here, and then we can solve it with dt. All right, so we have dt equals dx over u. So instead of u, we are going to take this expression that we already get. So now shift this onto the left side, so we can easily integrate, because we have only the expression in terms of t, and these y naught and x naughts are just constant. So we not need to be worried about these constants, and we can simply integrate the function. So we will get x equals t to the power 4 over 24 plus y naught t squared over 2 plus x naught t plus, let's call it c2. Now we know that the initial condition for x is simply x of 0 equals x naught. So plug in x naught equals, and for t, it's t of 0 is 0. So this is 0 plus this will be 0 plus this will be 0 again, plus this will be c2. So this implies that c2 is nothing but is simply x naught. So the expression equation 3, if we call it equation 3, this equation number 3 becomes x equals t to the power 4 over 24 plus y naught t squared over 2 plus x naught times t plus 1. Okay, so now this is one more expression we get by using the pairs. And now we need to do is we need to find a journal expression for u in terms of x, y, and t. Okay, so now we can just use some substitutions. As we can see that here, we have u equals to t cube over 6 plus y naught t plus x naught. If we are able to find these x naughts and y naught, then we are just going to answer the problem for u. So from this expression, if you want to work out for y naught from here, this implies that y naught equals y minus 2t squared over 2. So, and from here we have x naught, expression for x naught, that is x naught is equals to x minus t power 4 over 24 minus y naught t squared over 2 and divided by t plus 1. T plus 1, and again for this y naught we need to uh, just put the value of y naught that we already have. So it's t power 4 over 24 minus y naught is just t squared over 2 minus y times t squared over 2 divided by t plus 1. So now we have the expressions for x naught and y naught is equals to t squared over 2 minus y. Let's check it again if this is correct. Y naught equals y minus t squared over 2, sorry. It's y minus t squared over 2. So it's y minus t squared over 2. So we have y minus t squared over 2. And again here we have y minus t squared over 2. T squared over 2. Okay. So what we can do here is now simply plug these values in u, where u is equals to t cube over 6 plus y naught times t. So y naught, we have y minus t squared over 2. So y minus t squared over 2 times t. And then we have plus x naught. So x naught, we have x minus t to the power 4 over 24 minus y minus t squared over 2 divided by 2 and times t squared, and this is just whole divided by t plus 1. So now we get the result for u in terms of x, y, and t. So this is actually the required result, and we can verify the condition and the equation as well, and we can simplify this expression as much as we can. And if you want to plug in the initial conditions, so we plug here if t cube is 0. So if we want to verify the initial condition, so u of x comma y comma 0 equals it will be 0 plus 0 plus x plus minus 0, and then again here is t squared, so this expression also will be 0, so we will left with x. So the initial condition is verified, and you can also verify the equation as well. So this is the construction of the solution for a quasi-linear first order partial differential equation in more than 2 dimensions, or you can say having more than 2 independent variables, like in this case. So hope you guys will learn from this lesson. Thanks for watching the lesson. That's all for the time being. We'll come up with more lessons in the next class.